Every year, America throws away more than 10 million tons of glass bottles and jars. But what if we told you that mountain of broken glass can be reborn into something soft, light, and incredibly powerful? Welcome to the supergiant recycled glass wool plant, where discarded glass gets a second life as one of the world's most effective thermal insulation materials. From molten furnaces glowing at 1400 degrees Celsius to hair-thin fibers spun faster than a jet engine turbine, this is the mind-blowing transformation of recycled glass into soft, fluffy insulation that keeps America warm, efficient, and sustainable. Glass is one of the most recyclable materials on Earth. It can be melted and reused endlessly without losing quality. Yet in the US, nearly 1/3 of all glass waste still ends up in landfills. That's where plants like this one come in. Massive recycling and manufacturing complexes, stretching over 40 acres, combining recycling, refining, and insulation production under one roof. At first glance, it looks like any industrial site: conveyors, silos, furnaces, endless smokestacks. But what happens inside is a masterpiece of engineering and sustainability. Every day, hundreds of recycling trucks arrive at the facility, loaded with crushed glass from homes, restaurants, and factories across the region. The operation runs 24/7, turning what was once waste into gold for the energy-efficient future. The journey begins in the sorting hall, where glass waste is dumped into massive hoppers. Here it's a chaotic mix: green beer bottles, clear jars, brown containers, even bits of porcelain and metal caps. To transform this into usable material, precision is key. Giant vibrating screens shake the material, separating large pieces from fine dust. Next, powerful magnets remove metals like steel or aluminum. Optical sorting systems, guided by AI-powered cameras, scan thousands of glass fragments per second, identifying colors and compositions. Air jets then blow unwanted pieces off the conveyor. It's like a laser orchestra, sorting 20 tons of glass every minute. What remains is clean cullet, tiny pure shards of glass ready to be reborn. And the numbers are staggering. Each ton of recycled glass used in production saves over 1.2 tons of raw materials, reduces energy consumption by 30%, and prevents hundreds of kilograms of CO2 emissions. Sustainability isn't just a slogan here, it's built into every step. From the sorting line, cullet travels on long conveyor belts to the melting furnaces, the fiery heart of the plant. Each furnace is as long as a passenger jet, burning day and night at temperatures over 1,100 degrees Celsius. Here, recycled glass mixes with natural materials like silica sand for structure, soda ash to lower melting temperature, limestone to improve durability, and tiny amounts of boron for thermal resistance. As the mix heats up, it transforms into a glowing, honey-like molten glass, swirling and bubbling under flames of natural gas and oxygen. The sound inside the furnace hall is like a living creature, a deep roar that never sleeps. Operators in control rooms monitor the chemistry, adjusting oxygen flow and temperature to ensure perfect melting. Because even a few degrees too hot or too cold can ruin an entire batch. In one day, this plant melts over 500 tons of glass, enough to insulate thousands of homes. Now comes the magic, turning liquid glass into something softer than cotton. The molten glass flows through platinum nozzles into high-speed spinning wheels, rotating at over 6,000 RPM. As the glass hits the edge of these spinners, centrifugal force flings it outward, stretching it into hair-thin fibers, some just 1/1/7 the thickness of a human hair. Jets of hot air shape and carry these fibers downward through a tall forming chamber, a blizzard of glowing threads floating like snow. Within seconds, molten glass becomes a soft, tangled web of fibers, the foundation of glass wool insulation. It's mesmerizing. Fire transformed into softness, strength, and silence. The chamber's airflow and humidity are precisely controlled to ensure the fibers interlock perfectly. Robotic arms continuously spread the mat to maintain uniform density. Freshly spun glass fibers alone are fragile. To give them structure and resilience, they're coated with a binder resin, a plant-based adhesive that holds fibers together. Older generations used formaldehyde-based binders, but modern eco-plants in America have switched to biopolymers and sugar-derived resins, reducing emissions and odor. As the fiber mat moves along the conveyor, automated sprayers coat it evenly. Then it passes through a curing oven heated to around 250 degrees Celsius, 480 degrees Fahrenheit. Inside, the binder hardens, bonding the fibers into a flexible, springy mat that can bend, compress, and bounce back into shape. By the time it exits the oven, what started as molten glass now feels like soft wool, warm, light, and ready to protect buildings from heat and noise. From the curing line, the continuous mat is trimmed by precision lasers and cut into standard sizes. Some are rolled into compact bundles for home insulation. Others are cut into rigid panels for industrial applications, power plants, data centers, or high-rise towers. The rolls are then compressed by automated packing systems. Here's where the genius of glass wool shines. It can compress up to 10 times its original volume without losing performance. That means more material per truckload and fewer emissions during transport. High-speed robots seal each roll in airtight, recyclable plastic film. Labels are printed automatically, showing density, R value, insulation performance, and batch codes for traceability. Finally, pallets of finished insulation travel down conveyors toward massive warehouses, ready to be shipped across America. Each roll carries the story of sustainability, born from waste, forged by fire, and destined to save energy for decades. Before any product leaves the factory, it must pass through a gauntlet of quality control tests. In the acoustic lab, technicians measure how well the insulation blocks sound waves, a crucial feature for schools and offices. In the thermal lab, samples are placed between heated plates to test their resistance to heat flow. The higher the R value, the better the insulation. And in the compression lab, powerful hydraulic presses squeeze the material to ensure it rebounds to full shape, every single time. Even color and fiber uniformity are scanned by AI systems, comparing each roll to reference standards. Only after passing every test does a batch earn its ENERGY STAR certified label. Most people never see insulation. It hides behind walls, underfloors, and above ceilings. Yet it's one of the unsung heroes of modern energy conservation. By installing glass wool insulation, American homes save billions of kilowatt-hours of electricity every year, reducing heating and cooling costs by up to 40%. Over its lifetime, 1 ton of glass wool saves more than 500 times the energy used to make it. That's the power of recycling at scale, turning trash into tools for a sustainable future. At this plant, sustainability doesn't end with recycled glass. Even the heat from furnaces is recovered through heat exchangers to warm nearby offices and melt new batches of cullet. Dust from fiber formation is captured by filtration towers and reintroduced into the melt. Nothing goes to waste. If you enjoyed this journey inside the world of industrial recycling, don't forget to hit like, subscribe, and tap the bell icon so you'll never miss our next exploration into the hidden factories that power our planet. Thanks for watching, and see you in the next adventure. Every day, Americans throw away over 700,000 tons of garbage, enough to fill more than 60,000 garbage trucks daily. Imagine that. Mountains of trash stretching from coast to coast, piling up faster than we can bury it. But what if that waste didn't have to end up in a landfill? What if it could become electricity? Welcome to the supergiant waste-to-energy plant, where engineers and scientists have turned the nation's garbage problem into a source of clean, renewable power. Today, we'll journey deep inside one of America's most advanced facilities to see how mountains of trash are transformed into megawatts of energy that light up homes, power cities, and reduce landfill waste in a mind-blowing process. America produces over 292 million tons of municipal solid waste every year. That's about 5 pounds of trash per person per day, the highest in the world. For decades, most of that waste was simply buried in landfills. But landfills release methane gas, one of the most powerful greenhouse gases on Earth. In the 1970s, engineers started asking a radical question. If trash contains energy, why are we just throwing it away? That question led to the birth of the waste-to-energy (WTE) movement. Instead of burying trash, these facilities burn, gasify, or process waste to recover usable energy, mostly electricity and heat. Today, more than 70 waste-to-energy plants operate across the United States, handling over 30 million tons of garbage every year. Each ton of trash processed here generates enough power to light up a home for 2 weeks. But how do they do it? Let's dive inside one of the most advanced and massive of them all. The story begins at every home, business, and city street corner. Garbage trucks collect tons of mixed waste, food scraps, packaging, plastics, papers, broken furniture, and head toward the enormous waste-to-energy facility. When the trucks arrive, they enter a giant reception hall, larger than a football field, known as the waste bunker. Here, operators dump the waste into a massive pit that can hold 10,000 tons of garbage at once. Towering overhead, crane operators maneuver giant claws, each weighing several tons, to mix the waste, ensuring an even blend of materials. This helps the combustion process later on. Every few minutes, a claw grabs nearly 5 tons of trash, lifting it high above the pit and dropping it into the feed hoppers, where it begins its incredible transformation. Inside the heart of the plant lies the furnace system, an engineering marvel where temperatures exceed 1,800 degrees Fahrenheit. Here, the waste travels along moving grates, slowly burning in controlled stages. Unlike an open fire, this is a precisely managed combustion process that maximizes energy recovery and minimizes emissions. As the garbage burns, it releases hot gases and energy. That heat is captured in boilers filled with water, converting it into high-pressure steam. This steam then drives massive turbines, the same kind you'd find in power plants, generating electricity that flows directly into America's power grid. Every ton of waste burned produces about 550 kilowatt-hours of electricity. Enough to power a modern refrigerator for an entire year. Meanwhile, the combustion process reduces the original volume of trash by nearly 90%, leaving behind only ash, which can be further processed to extract metals or used in road construction. Now you might wonder, doesn't burning trash pollute the air? That's where cutting-edge technology steps in. Modern waste-to-energy plants are equipped with multi-stage filtration systems that remove harmful gases, heavy metals, and particulates before anything is released into the atmosphere. The result? emissions cleaner than most industrial facilities, often meeting or exceeding EPA's strictest air quality standards. At the same time, magnets and eddy current separators recover ferrous and non-ferrous metals from the ash, such as iron, copper, and aluminum, which are then sent to recycling centers for reuse. So not only does this process generate power, but it also recovers valuable raw materials that would otherwise be lost. The electricity generated by these supergiant plants is nothing short of astonishing. A single large facility can produce up to 70 megawatts of continuous power, enough to supply energy to over 60,000 homes. And across the US, all waste-to-energy plants combined generate around 2.5 gigawatts of electricity annually. But the benefits go beyond power generation. Each ton of waste processed here prevents 1 ton of CO2 emissions that would otherwise come from methane in landfills. Additionally, by recovering metals and reducing waste volume, these plants save millions of square meters of landfill space every year. It's a perfect example of a circular economy, where even our garbage becomes a resource. The concept of turning waste into energy isn't new. The first incineration plant in the US opened in 1885 in New York City, mainly to reduce the city's waste problem. But early facilities were inefficient and heavily polluting. It wasn't until the 1970s energy crisis that the idea gained momentum. With oil prices skyrocketing, cities began exploring ways to extract energy from their waste. By the 1990s, with advancements in combustion control and emission technology, waste-to-energy plants became one of the most regulated and efficient energy sources in America. Today, facilities like Covanta's Energy from Waste plant in Florida or Wheelabrator, Baltimore, process millions of tons of garbage annually, producing reliable, renewable electricity while keeping landfills in check. And as technology continues to evolve, engineers are now exploring plasma gasification, anaerobic digestion, and carbon capture integration. Turning what was once pollution into clean energy solutions for the future. If you found this journey fascinating, from garbage trucks to glowing cities, hit that subscribe button, give this video a like, and ring the notification bell, so you never miss another deep dive into the incredible world of mega factories and mind-blowing industries. Because here, every pile of trash hides a story of transformation, and we're just getting started. Everywhere you look, cars, bridges, skyscrapers, tools, steel is the backbone of modern civilization. But here's something that might surprise you. Most of America's steel doesn't come from the ground. It comes from our old cars, appliances, and demolished buildings. This is Steel Without Mining, the story of how America turns mountains of scrap metal into the world's most useful material again and again, without digging a single ounce of new ore.